So welcome Algebra 1 to the first video worth of new stuff only. 8.1 has a companion notes sheet, so let me describe it to you and then find it before you listen on, and you can pause the video if it's not in your hands yet. It should say at the top, Algebra 1, 8.1. Then there's a big box around the sentence that says, 1 chapter from now you will need to own graph paper. So someday when we get up to chapter 9, you'll need to own graph paper to do that. Then it says that the chapter is about a thing called rational expressions. Rational is a word that's always meant there were fractions. 7th grade, even we studied ratios, were fractions. So what we have going is fractions that have polynomials in them. The board at present is full of a whole bunch of examples of rational expressions because there's fractions everywhere. And then this has a monomial, this has a binomial, this has a trinomial, but all over the board they're all polynomials on the top and on the bottom. So the first topic, and on this paper basically what you already have is the board you would have seen just without any of the answers on it. That's how my notes are. I always write the problems but not the answers. Except these first few. I already have the answers written on the first few. So the original problems were intended to be these. You already have the answers before we do the thing, so you're already ahead of the game. But you can kind of fill in the answers and listen as we go and fill in the work. But I work from these notes. You're also working from my same notes every day. It'll be like the board's already in your hands. You don't have to come into class and write it down. It's just there. So the first idea in this is that sometimes the fraction is undefined, is the word our Algebra 1 book uses. The ruling on this is nothing is ever allowed to have 0 on the bottom. And so what we're going to seek out is, are there numbers that could make the bottoms 0? And if so, we're going to create what's called a restriction and say, no, that number is not allowed. So basically, what you're going to do is ignore the tops. The tops have nothing to do with this restriction concept. You ignore the tops, and you just look at the bottoms and think, if this bottom equals 0, is there a way that that can happen? If you solve that for x, do the opposite. Since it's subtracting 4, you'd add 4 and come up with 4. The number 4, if you put it in, would make the bottom 0, and we want to say, no, that's not allowed. So we're going to use this symbol, and that's our answer to say, x could never be allowed to equal 4, because if it were, it makes the bottom 0, and math does not allow that. So for this, if you think about if there's a way the bottom could equal 0, you'd subtract the 4, you would divide by the 7, and then you need to say we are not equaling that. If you forget to do the slash through it, you couldn't possibly be more wrong. It would be the total opposite of what we want to say. We want to say x is not 4, so there are not going to be equal signs in the answer space. To do this one, this is the easiest one. If you let this equal 0, well, that's already done. As an answer, we just need to say, no, don't do that. This one, you'd have to factor. So hopefully you've had success on factoring last week. This is a difference of squares, so we're x and x. We're different signs. We have a pair of 3's. And then we go one step beyond that as we were in chapter 7. What would make this factor 0 is a negative 3. We used to change the signs. What would make this 0 is a positive 3 if we change the signs. But to have a full answer, we need to be saying, no, we are not allowed anymore to have x be those things because they were on the bottom and we're doing a new thing with that. This is also a factor, x and x. Minus means different signs. 6 and 2 create the subtractive 4. 6 is minus, 2 is plus. So negative 2 is the solution normally for that. Positive 6 normally for that. But today we're saying x is not allowed to be those things. And that's topic 1 of the day. Topic 2 of the day, you're going to be asked to simplify. So when you go to simplify, what we're trying to do is factor anytime there's adding or subtracting, because then we're going to cancel. You're only allowed to cancel when things are multiplying. You're not allowed to cancel when adding and subtracting is in the neighborhood. So if you see adding or subtracting, factor, all those skills we've been working on lately, and then we're looking to cancel. In the homework on the 318, the first 8 is like what we just did, talking about our restrictions and things being undefined. Starting on 9, we're about to do what I'm about to do. So this has no adding in the area. So we can just straight out start to cancel. 12 on top of 40 is just a fraction to reduce. I'm going to reduce that by 4s. And if you eliminate some x's, there's a little bit more on the bottom. 3 x's on the bottom can bump off the 2 on the top. There's just a spare x on the bottom. And that's how we're looking to simplify. This, there is adding in the area, so we can't go ahead and cancel. We have to factor first. The top has a 4 that can be factored off as a GCF. To leave that. 18 on the bottom. X plus 4 is stuck, but 4/18 is a reducible fraction to 2/9. That's the way I'm supposed to show you how to do that. I have an alternative plan that's harder to explain why. Wait till I'm in person sometime and I can tell you why. But if we look at all these numbers, we could do a thing that I've termed triple play reducing. Don't go to a new school and start talking about that, because that's just my pet name for this personally. No one will know what you mean. What I mean is these numbers can all be divided by 2. If I can divide all of those numbers by 2, I'm just going to do it. This is really the same as what we got. This has been factored a little bit more than this, but they're the same, and I would not care which answer you did. If this were a 17, you can't do it, because nothing goes into anything. So this would be another example of one that I could go ahead and just triple play reduce. This, and this, I can divide them all by 2, and just skip the 3x plus 10 on top of 2. If you don't get that, then don't do that. That's just a trick. And it's harder to justify. This I can factor a 2 off, 3x plus 10 on top of a 4. 3x plus 10 is stuck. 2/4 can reduce to a half. I only need the 2. The invisible 1 can go invisible. We don't need it. If you put it, it wouldn't hurt anything, but I don't see a use for that. This on top, I could take out a 12. That's 2x plus y. The 12 could cancel the 6 to leave a 2. 2x plus y. There's no more bottom because we canceled it. If you like that triple play thing, you could have done that here too. 6 goes into everything. The bottom died at that point, don't even write a bottom, but if you want to take 6 into everything, you're good. But again, that triple play thing only works if it goes into every single coefficient, every single number. This we can't do any kind of quadruple play reduce, because there's no number that goes into every number, so we've got to just do the basic strategy is factor the GCF of 2. On the bottom, factor a GCF of 3. Match, match, gone, gone. 2/3 is the winner. This one, top, factor again, GCF. 2 goes into everything, leaving x minus 4. On the bottom, it's like the base problems that you were very good at last time we saw each other face to face, x and x. The plus means these are the same as that, so minuses, 4 and 3. Cancel matches, has to be a perfect match, those are a perfect match. The answer would have 2 on top, x minus 3 bottom. If you think you got it, pause the video. We're usually in class, I would say, like, try some now. Okay, so if you want to see if you got it, pause it, try some, see if you agree with me. At any point in any video, you could do that. Hey, I think I got it, let me see. Try it, let it reveal itself. That's probably a better way to learn than listen to me is, as soon as you think you got it, jump on it, just do it. You see all the problems, just see if you can do it. Top of this, I'm going x plus 6, x plus 1. Bottom of this, I'm going x plus 7, x plus 1. Since those match, I go x plus 6 over x plus 7. This one, I'm going y plus and y minus because of the different signs. Plus takes the bigger number, which will be 4 and 2. 4 times 2 to get the 8. When they're different, subtract to make the middle. The bottom's a difference of squares. 2 minus y and 2 plus y. And then here's a small twist. I told you we needed perfect matches to cancel, which is almost always true. This is a slightly imperfect match. They're the same things, but they're subtracting backward. Anytime you subtract backward, the only thing that changes is the sign. So if you get a subtract backwards, go ahead and cancel it, but we get a sign change out of that. So the answer on this would be a y plus 4 on top, a 2 plus y on the bottom, a minus in the front, and we're good. If one of these had gone backwards, okay, let's say this is 1 plus x compared to x plus 1 as a what if, you would not have to pay for that in any way with the sign, because you can switch the order of adding anytime you want with no payment. That's the commutative property of addition. Adding, you can switch it, so if you ever have add out of order, don't worry about it. But if your subtract is ever out of order, there's always a payment to be made. So this one, the bottom, we're going to have to factor with the guess check system, 2x and x. Sign is minus, so we need them to be different. I'm going to go plus minus, but you might guess that first wrong and have to eventually switch it, but it will work this way. To do 5, we need 5s and 1s. You could guess your way around. 5, 1 is going to be the way it works, because this made a negative 1x. This made a positive 10x. Together, that's a positive 9x, and I am good. Invisibly, this is in parentheses. We've talked about that before. The top has parentheses, whether they're written or not. If you want to put them in, put them in. This matches this perfectly, because as I just described, we can add backward and there's no harm done. Answer for this has a 2x minus 1 on the bottom. With an empty top, you need a 1 to fill the gap. A minute ago, we had an empty bottom on this. We did not need a 1 on that. We could just leave that blank. But empty top, we need a 1. On the test, I don't think the questions are separate the way the homework is. The homework has you, oh no, they do. Okay, so all of these problems are semi-incomplete because they're asking us now to do restrictions as well. So if I want to do restrictions on this, I'd say x not allowed to equal, and I'd look to the bottoms. This would lead me to negative 5. This would lead me to positive 1/2. I probably don't need to do that 10 more times because we did that 5 times at the beginning. For any of these that need restrictions though, we're just going to go x not allowed to equal, look at the bottom, with a minus 3, you do a 3. For this, I look to the bottom, x not allowed to equal, this tells me 4, this tells me 3. Even if I crossed it out, it still needs to produce a restriction. It was there at the beginning, it counts toward the restriction thing. Even though the x minus 4 got eliminated, we still need the 4 as an answer. So this, and then all cut out for the day, we'd say x not allowed to equal. We'd look at these two things, negative 7 here, negative 1 there would be our 2 answers. Hope that helps. If you have further questions, send me an email. I'll try to do those at a future time. See ya.